7th December, 1941, just before 8 o'clock in the morning. Pearl Harbor, territory of Hawaii. Battleship Row is already burning. Black smoke rises in columns above the anchorage as fuel ignites across the water. The battleship Arizona is gone within minutes, torn apart by a magazine explosion that kills more than 1,000 sailors almost instantly. Nearby, Oklahoma rolls slowly to port and capsizes, trapping hundreds inside. West Virginia settles on the harbor bottom, her decks awash. California sinks at her moorings. Nevada, damaged but still moving, is deliberately beached to keep the channel clear. By the time the last Japanese aircraft withdraw, the United States Pacific Fleet has been shattered at anchor. What remains afloat is damaged. What is damaged cannot fight, and what is sunk cannot be repaired quickly. The attack on Pearl Harbor is remembered as a failure of warning, of air defense, of intelligence. But within hours, a deeper problem becomes apparent, one that no amount of bravery or firepower can immediately solve. The United States Navy has lost its ability to repair battleships forward. Pearl Harbor is not just a base. It is the only major dry dock facility in the Central Pacific capable of handling capital ships. And on that morning, the dry docks themselves are damaged, flooded, or overwhelmed. Dock space is immediately consumed by emergency salvage operations. Every ship that can be saved demands priority. There is no spare capacity, no margin. A battleship cannot be repaired at sea. A cruiser cannot be dry docked offshore. Hull breaches, damaged propeller shafts, bent rudders, torn plating below the waterline. These are not problems solved with patchwork or courage. They require dry docks, fixed, massive structures anchored to land. Structures that are rare, vulnerable, and immovable. Beyond Pearl Harbor, the nearest full-capability naval shipyards lie thousands of miles away. Mare Island Naval Shipyard, California. Puget Sound Naval Shipyard, Washington. To reach them, damaged ships must cross the entire Pacific Ocean or be towed at reduced speed, often without full propulsion, under constant threat from submarines. A single torpedo strike against a crippled ship can finish what Pearl Harbor began. A damaged battleship is not merely out of the fight. It is removed from the war for months. This reality collides immediately with geography. The Pacific is not the Atlantic. There are no closely spaced ports, no dense web of repair facilities. Vast distances separate every operational area. The ocean itself is the battlefield, and it offers no infrastructure. As the war unfolds, American strategy begins to take shape around island hopping, seizing forward positions, one by one to push toward Japan. But these islands are not ports. They are coral atolls, jungle-covered ridges, volcanic rock. They possess no docks, no cranes, no shipyards. The Japanese Navy operates close to home waters, supported by established bases in the Western Pacific. The United States Navy operates at the end of an ever-stretching supply line, extending from the West Coast across thousands of miles of open ocean. Every engagement carries an unspoken risk. Not whether a ship will survive the battle, but whether it can survive the journey home afterward. In the early months of the war, this imbalance becomes clear. Ships damaged in combat are forced to withdraw completely from the theater. Some never return. Others arrive back in American yards, stripped of their crews, their operational momentum lost. The United States can build ships faster than any nation on Earth. American shipyards will eventually launch thousands of vessels, destroyers, cruisers, carriers, auxiliaries, at a pace unmatched in history. But production alone is not victory. A navy that cannot repair its ships near the front cannot sustain pressure. It fights in waves, surges forward, then retreats to recover. Time is lost. Initiative slips away. Pearl Harbor has revealed a hard truth. The problem is not courage. The problem is not ship design. The problem is infrastructure. The United States Navy has no way to repair battleships forward. As planners assess the wreckage in Hawaii and project the coming campaigns across the Pacific, a question begins to dominate every serious discussion of naval strategy. How do you keep a fleet fighting when the ocean itself is your front line? And how do you repair a battleship when there is no land to stand on? The problem exposed at Pearl Harbor was not new. Naval engineers had been warning about it for decades. Long before the first Japanese aircraft appeared over Oahu, officers within the United States Navy's Bureau of Yards and Docks, known as BUDOCS, had studied the vulnerability of fixed infrastructure. Dry docks were essential, but they were also immobile, predictable, and easy to target. A single bomb or torpedo could disable a facility that took years to construct. During World War I, the Navy had experimented with floating docks to support operations overseas. These structures were crude by later standards, but they proved an important principle. A dock did not need to be anchored to land to lift a ship. It only needed buoyancy, strength, and control. British engineers reached similar conclusions. Facing global commitments across the empire, the Royal Navy explored sectional dock concepts that could be transported and assembled in remote locations. The idea was not revolutionary. The execution, however, remained limited by industrial capacity and scale. What changed after Pearl Harbor was urgency. The United States Navy Civil Engineer Corps, working through BUDOCS, reframed the problem entirely. The question was no longer how to protect fixed dry docks. It was how to eliminate dependence on fixed dry docks altogether. The requirement that emerged was clear and uncompromising. Any solution had to be modular, so it could be transported in pieces. It had to be towable across oceans. It had to be scalable, capable of handling everything from destroyers to battleships, and it had to be built in numbers. The result was the Advanced Base Sectional Dock Program. The ABSD was not a single structure. It was a system. At its core were steel pontoon sections, massive hollow units designed to float independently. Each section was engineered with ballast tanks, pumping systems, and structural reinforcement. On their own, they resembled oversized industrial barges. Together, they formed something entirely different. When assembled side by side and connected longitudinally, these pontoons became a floating dry dock. Water could be admitted into the ballast tanks, allowing the dock to sink beneath the hull of a damaged ship. Once the ship was positioned, the tanks were pumped dry. The dock rose. The ship came with it, lifted clear of the water. This was not theory. It was physics applied at scale. Fully assembled ABSDs were capable of lifting tens of thousands of tons, enough to raise cruisers, carriers, and even battleships for underwater repair. Hull plating could be cut and replaced. Propellers and shafts could be removed. Rudders damaged by mines or torpedoes could be repaired without sending a ship halfway around the world. Most importantly, the dock itself remained afloat. It did not depend on shoreline foundations. It could be positioned wherever sheltered water existed. And because the system was modular, it could grow. If a larger dock was needed, more sections were added. If one section was damaged, it could be isolated and repaired without disabling the entire structure. This flexibility played directly to American strengths. Construction of ABSD sections was distributed across the industrial base. Shipyards in California, along the Gulf Coast, and in the Great Lakes region fabricated the pontoons in parallel. No single facility became a bottleneck. No single attack could halt production. Once completed, the sections were launched and prepared for transit. Some were towed through the Panama Canal. Others took the longer route around Cape Horn. Each journey carried risk. These were enormous, slow-moving structures crossing waters patrolled by enemy submarines. Their loss would not be measured in sunk tonnage, but in delayed strategy. Assembly sites were chosen carefully. They were not ports in the traditional sense. They were anchorages remote, undeveloped locations selected for depth, shelter, and proximity to operations. Espiritu Santo in the New Hebrides, Mare Island in the Admiralty Islands, Ulithi Atoll in the Caroline Islands. These places had no shipyards when the war began, no dry docks, no infrastructure. What they offered was space and water. The first sections arrived to little more than jungle, coral, and open sea. Assembly itself was an engineering operation conducted under wartime conditions. Sections had to be aligned precisely. Structural connections were installed afloat. Power, pumping, and control systems were integrated on site. There were no existing facilities to support the work. Everything had to be brought with the dock or built as needed. The risks were considerable. Towing operations stretched across thousands of miles. Enemy submarines hunted supply routes aggressively. A single torpedo could cripple a pontoon or scatter a convoy. Assembly crews worked in undeveloped anchorages without shore-based protection or redundancy, and there was no precedent for operating floating docks of this size so close to combat zones. Yet the alternative was unacceptable. Without forward repair capability, the Pacific Fleet would continue bleeding ships back to the West Coast. Time would be lost, momentum would be lost. The initiative would remain contested. By mid-war, the first ABSD installations were complete. Steel towers rose from calm anchorages. Pumps came online. Ballast tanks flooded and emptied as designed. The system worked on paper, in trials, and now in position. The dock was finished. The question was no longer whether it could be built. The question was whether it would work under combat conditions. The first true test of the advanced base sectional dock system came far from any traditional shipyard. Late in 1942, at Espiritu Santo in the New Hebrides, ABSD-1 became operational. The location was chosen for necessity rather than comfort. Espiritu Santo was little more than an anchorage supported by hastily constructed shore facilities. There were no permanent docks, no heavy industrial base, yet it sat close enough to the Solomon Islands to support ongoing combat operations. For the first time in the Pacific War, damaged American warships no longer had to turn east. Cruisers and destroyers battered during the Guadalcanal campaign began arriving at the floating dock instead of setting course for Pearl Harbor or the West Coast. Hull damage from shellfire and near-miss explosions was lifted clear of the water. Bent propellers were removed and replaced. Rudder assemblies damaged by underwater shock were repaired in place. What had once taken months now took weeks. In some cases, days. The change was not dramatic in appearance. There were no headlines, no victory announcements. Ships slipped quietly into the dock and quietly returned to the fleet, but operational tempo shifted almost immediately. Commanders no longer hesitated to commit ships aggressively for fear of losing them to prolonged repair cycles. A damaged ship was no longer a strategic loss. It was a temporary inconvenience. As the war expanded across the Pacific, the system expanded with it. Additional ABSDs were deployed forward. Each new dock extended the Navy's reach. Each reduced the distance between damage and repair. The effect compounded over time. During the long and costly struggle for Guadalcanal, American forces had learned the price of operating without forward repair. Ships damaged in night actions or air attacks often vanished from the theater for months. Their absence was felt in every subsequent engagement. By the time operations shifted westward, that absence disappeared. In 1944, during the Battle of the Philippine Sea, American carriers and escorts absorbed damage from air attack and operational strain. The scale of the engagement was enormous. Aircraft losses were heavy. Ships were stressed to their limits. Yet damaged vessels did not withdraw across the Pacific. They withdrew to floating docks. Propulsion systems were repaired forward. Hull damage below the waterline was addressed within the theater. The fleet's effective strength remained intact, not because ships were invulnerable, but because they were recoverable. The Japanese Navy could not match this tempo. Japanese warships depended on a limited number of fixed repair facilities in the home islands and a handful of forward bases. As American submarines tightened the blockade and air power extended deeper into the Western Pacific, those facilities became increasingly vulnerable. When Japanese ships were damaged, they often faced an impossible choice: risk a long, exposed journey home for repairs, or remain forward with reduced capability. Many never made it back. By the time of the Battle of Leyte Gulf in October 1944, the difference in logistical resilience was stark. American ships damaged during the largest naval battle in history were repaired forward and returned to service. Japanese losses, by contrast, were permanent. The battle ended the Japanese Navy as an effective fighting force, not solely through destruction, but through exhaustion. And exhaustion is a logistical condition. The culmination of this system emerged at Ulithi Atoll. Captured without opposition in September 1944, Ulithi became the largest naval anchorage in history. Its lagoon sheltered hundreds of ships at a time: carriers, battleships, cruisers, destroyers, auxiliaries. What it lacked in natural infrastructure, it gained through engineering. Multiple advanced base sectional docks operated within the lagoon. Ships arrived damaged and departed repaired. Crews rested while maintenance crews worked. Fuel, ammunition, and supplies flowed in continuous cycles. The fleet did not disperse between operations. It remained concentrated, ready, and sustained. Ulithi turned the ocean into a base. From there, American forces struck Iwo Jima, then Okinawa, then the Japanese home islands themselves. Kamikaze attacks inflicted damage that would have crippled fleets in earlier wars. Instead, ships rotated through forward docks and returned to the line. The system absorbed punishment and continued functioning. This was not accidental. It was not improvisation. It was the product of deliberate planning that treated repair as a combat function rather than a rear area task. The Pacific War was not won by any single battle. It was won by maintaining pressure without pause. Japan built excellent ships. Their designers produced powerful battleships, fast carriers, and capable cruisers. Their sailors fought with skill and determination. But their naval system assumed periods of withdrawal, refit, and recovery. The American system did not. By building modular, mobile repair infrastructure, the United States Navy eliminated the concept of rear areas. The front line moved, and the infrastructure moved with it. The ocean itself became a platform for sustained warfare. Advanced base sectional docks were not glamorous. They did not fire guns or launch aircraft. They appeared in no dramatic photographs. Yet they quietly determined how long ships stayed in the fight. They turned damage into delay instead of defeat. By 1945, the outcome was irreversible. American fleets operated continuously at the edge of enemy territory. Japanese forces could not recover from losses fast enough to contest control of the sea. The war ended not when ships were destroyed, but when one side could no longer keep ships operational. That difference was built, section by section, in steel. The Advanced Base Sectional Dock program did not win the Pacific War alone, but without it, victory would have taken far longer and cost far more. The lesson endured. Modern naval doctrine treats sustainment as inseparable from combat power. Fleets are judged not only by what they can strike, but by how long they can remain engaged. That principle was proven across the Pacific. The United States did not merely fight on the ocean. It built infrastructure on it. And in doing so, it transformed logistics into a decisive weapon of war.